Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at differentiating linear combinations. So a linear combination of a function is just like this. Something times a function of x plus something else times another function of x. So when we differentiate things in this form, we don't always want to use first principles because that takes a long time. It can get very impractical. So instead, we're going to use these rules here for differentiation. So this first one says the derivative of a constant is 0. If you want to differentiate a power of x, you just move the power to the front, decrease the power by 1. Derivative of cos is negative sign, derivative sign of cos. We already saw the derivative of e to the x is itself, and the derivative of the natural log of x is 1 over x. So using these rules in conjunction with this one, we'll be able to differentiate heaps of different functions nice and quickly. So this rule here for linear combinations says that if you have something times a function of x plus something else times another function of x, you simply differentiate the first function and multiply it by the constant, differentiate the second function, multiply it by the constant, and add them together. This rule allows us to, when we have a function that has many terms, differentiate term by term. So let's look at some examples. So let's start by differentiating this function here. This is a linear combination of functions of x, if you like. Each of these is a function of x. So we're going to differentiate term by term. So we're going to start by differentiating 3x to the power of 4. So the rule that we had on the previous slide, we're just going to times 3 by the derivative of x to the power of 4. So derivative of x to the power of 4, you move the power to the front and decrease the power by 1. Similarly, we're going to multiply the derivative of x cubed by negative 4. So it's negative 4 times, move the power to the front, decrease the power by 1. Derivative of x is just 1 because x is the same as x to the power of 1. So if you move it to the front, decrease the power by 1, you get 1x to the power of 0, which is 1. And the derivative of a constant is 0. So just writing this in slightly simpler form, we would get 12x cubed minus 12x squared plus 1. That is the derivative, that's the gradient function. It's the function into which I can substitute any value for x, and it'll tell me the gradient of the tangent to this curve at that point. So this is much easier than using first principles. Still important we know first principles so we know where all these derivatives come from, but now that we have a few rules we can differentiate a bit more efficiently. Alright, let's differentiate 4 over square root of x to the power of 3. So in a situation like this, it's probably easiest if we first write this as a power of x. So we're going to leave the 4 as it is for now. So 1 over square root of x to the power of 3. Well, square root of x to the power of 3, the power goes on top. Which root it is? Square root, second root, goes on the bottom. Now, because this is on the bottom of the fraction, we need to write it with a negative power. Now we've written it in this form, we can just use the power rule. So the derivative will be 4 times, so what we're going to do is move the power to the front and decrease the power by 1. So negative 3 on 2 subtract 1 is negative 5 on 2. So 4 times negative 3 on 2 gives us negative 6. And I'm going to move this part here down to the bottom. Usually you'll be asked to write any derivatives with only positive powers or as a radical. So x to the negative 5 on 2 goes on the bottom. Because it's a 2, we have a square root. The power goes inside the square root. So that's our final answer. All right, let's differentiate this one here. Once again, we differentiate term by term. So the derivative of sine is cos, so derivative of 2 sine x is just 2 cos x. The derivative of cos is negative sine. So this will be negative 3 times negative sine of x. Now, note for this last one, ln x on 2 is the same as a half times ln x. So we just differentiate ln x times it by a half. So that will be a half times derivative of natural log of x, which is 1 over x. So just writing this a little simpler, it will be negative 2 cos x plus, because of the two negatives, 3 sine x, and then 1 over 2 times 1 over x, I can just combine into a single fraction 1 on 2x, and we're done. Alright, let's now look at using this to find the equation of a tangent. So for the equation of a tangent at some value for x on the curve, we can use this formula to find the equation of a tangent. So it's the function evaluated at that point plus the derivative, so that's the gradient of the tangent, times x minus the x value in which we're interested. So we're going to calculate the equation of the tangent to fx equals 1 over x at the point 0.52. So first thing we're going to do is calculate f of x 0. So this here, 0.5, is like our x 0. So the function evaluated at 0.5 is 1 divided by 0.5, which is 2. Now we also need to evaluate the derivative at that point. That will tell us the gradient of the tangent to this curve at the point. So let's start by differentiating 1 over x. Well, what are we going to do here? We know that 1 over x is the same as x to the minus 1, so we're going to simply move the power to the front and decrease the power by 1. So it's negative 1 over x squared. So at the point 0.5, we're going to substitute 0.5. We actually get negative 4. That means the gradient of the tangent to this curve at that point is negative 4. So the equation of the tangent is going to be y equals f of x 0 plus derivative at that point multiplied by x minus x 0, which was 0.5. So just making this a little simpler, negative 4 times x, negative 4 times negative 0.5, we end up getting y equals 4 minus 4x, the equation of the tangent to this curve at that point. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.